Hello, you're listening to Poured Over, the Barnes& Noble podcast. My name is Chris Gillespie. My guest today is a best-selling author whose works include A Walk in the Woods, Notes from a Small Island, In a Sunburned Country, and A Short History of Nearly Everything, which he has recently updated, revised, and re-released as A Short History of Nearly Everything 2.0. Bill Bryson, thank you so much for joining us today.
Thank you for having me, Chris. I'm delighted to be with you.
I'm really looking forward to speaking with you today. I've been reading A Short History of Nearly Everything 2.0, and I've been really enjoying it. I was definitely a little intimidated at first when I first picked it up, but the way that you write is so engaging and accessible that I found myself learning a lot about topics that I haven't really given much thought to since high school, perhaps. For listeners who maybe aren't familiar with the original book, it's a massive, complex, ambitious project that covers everything from the origins of the universe to physics to chemistry, earth science, microbiology. It's basically a primer on the whole of human scientific understanding. I can only imagine how long it took you to research and write this book back when you were first putting it together, back for 2003. If I had written a book like this, I think I would be so burnt out afterwards that I would never want to touch it again. What drove you to revisit this book and all of this material 20 years later?
Well, it's because 20 years had passed. And what happened was, uh, I wrote the book and I was very happy with it. And then 20 years passed. And of course, science moves on. And,
Hmm.
and I looked at the book one day, not too long ago, a couple of years ago, and I thought, this is really getting out of date. And yet it was still selling. So it began to feel as if it was a little bit fraudulent
Hmm.
because the book was really getting quite dated, and a lot of the facts in it, a lot of the things I stated were no longer accurate facts because things had changed. I mean, one thing, just to give you one example, is to my amazement, I discovered that the number of moons in our own solar system has approximately doubled the number of known moons in this. And I just thought, when I read that, I thought, how did they not, notice all these moons 20 years ago? And the answer is that so many of them are really quite small. They may only be a mile or two across, and sometimes they're very, very far out from the planets they're orbiting. But it's just things like that. I mean,
Hmm.
the number of moons in Jupiter alone in 20 years has tripled. So there's just things like that was becoming out of date. So I thought I really, really must bring it up to date. And thinking that most of what I would do is I would just, kind of Google and fact check and change numbers here and there. And of course, it turned out to be a lot more complicated than that. I had to essentially go back and re-interview a lot of the people that I last talked to 20 years ago, and interview a lot of new people, which
Hmm.
I found a lot more work that I had bargained for, but it was actually a lot more fun and really, really enjoyable and fascinating. The things that have changed and the things that haven't changed, and what I had to the chapters that I had to work on the most in order to kind of bring them up to date.
Which of those chapters did required the most work, or that you kind of once you started working on it, you're like, "Ooh, wow, this is really getting a little old or stale." Was there any specific topic or field that needed the most attention?
Yeah, and both of them surprised me a lot. The two really big ones were our own solar system,
Hmm.
um, because of all these new moons and just all the things that have been discovered, asteroids and all kinds of things that have been discovered in 20 years. But also the fact that Pluto, when I wrote the book, Pluto was a planet, and now it's been downgraded and it's no longer a planet. It's something called a planetoid. Or a minor planet, but it doesn't count as a planet anymore. I mean, that was a really big deal in astronomy. But to lose a whole planet from your solar system is quite a big event, and so that chapter needed a lot of redoing. And then the other one that needed a huge amount of redoing was everything to do with human origins, all of the
Mm.
archaic early people, because the thing that has happened in the 20 years since I first read the book is that they have developed the science of paleogenomics, which is the ability to go in and do genetic, decipher DNA from ancient bones, which was something they couldn't do at all 20 years ago, and really didn't even dream of doing. Now they can go in and get really, really very specific, precise information, and lots of new species of early humans or human-like people have been discovered in the last 20 years. And so that meant that I had to completely rewrite two whole chapters.
I was thinking about this while I was reading the book and looking at the cover. Was there any discussion about changing the title of the book at all to a slightly less short history of nearly everything, now featuring more
It's
everything?
actually a slightly longer
Yeah.
short history really than it was before. This edition is plumper than the previous edition, partly because it just so much more had to be added. And I mean those two things that I just talked about were the main things but every chapter had changes in it. And of course, I mean, if you just think about it, all like particle physics, the Higgs boson
Hmm.
was discovered, and almost everywhere there's been developments and things that have had to be changed. So yeah, it became quite a big thing, and we had a lot of talk about how were we going to deal with this, how were we going to make it clear that this was essentially a new book. I mean, the old book, but in
Hmm.
a new version of the old book. And it was my one of my sons who came up with the idea, why don't you call it 2.0? So, which I thought was really very clever. It's quite obvious when you stop and think about it, but it was a kind of an inspired thought.
Turning back the clock a little bit when you were working on the first edition of the book, what was that initial inspiration for you to tackle a project like this?
Well, the initial thing was that I grew up in America, and I was bored out of my mind by science at school. I mean, I was terrible at it. I had no aptitude for it. Chemistry, physics, biology, all of those basic sciences, they were taught in a way that as if they were trying to train you to be a chemist or a physicist or a biologist, which is, I was never going to be.
Hmm.
So it just lost me on day one. As soon as the teacher turned around and started putting equations on a blackboard, I was lost. Just had no aptitude for it at all, and no interest in it in that kind of technical way. But I thought there's got to be some level at which even somebody like me can engage with science, because science is obviously very, very important. It tells us who we are, where we're going, how we got here, what we have to do to get where we want to go. I mean, everything there is that you're curious about in your existence, science is will provide the answers. And so I thought, I just thought, I feel bad that I don't understand more about where I come from and how the universe is put together, and all of that. But I want to do it in a way that doesn't involve a lot of equations and technicality, but it's really more like telling a story. So I got the
Hmm.
idea to do this, and I proposed it to my publishers both in New York and in London, and both of them said, "No, that's the most stupid idea they'd heard in a long time. Don't that was just no, don't do that. There's no future." So, but they indulged me and let me do it because I think they just wanted me to get it out of my system. And as it turned out, there were lots and lots and lots of other people just like me all over the world who, are never going to be scientists, but really would like to understand the universe and our place in it just a little bit better. And so the book I wrote was really based. It's not like a textbook, obviously. It's much more about a celebration of kind of
Hmm.
the wonder of our existence, of the amazing fact that we're here now, that you and I can talk, and that that all of these atoms have come together to make each one of us, and that we have this miraculous thing called existence that we get to live and breathe and think and do. Um, so that's what the book is about, really.
And as someone who is also was never going to be destined to become a scientist or an engineer or mathematician, I relate to that and connect to that and appreciate that because I do think that it is much more easy for a lot of people to be able to engage with this kind of material when it is presented as a narrative or through characters, sort of, because obviously scientists were real people, but getting to understand them as just that, real people and individuals rather than just names in a textbook, makes it all much more easy to connect to and relate to. You write a lot about a lot of different scientists and researchers all throughout the centuries in the book. Is there any one of those figures that you find to be the most interesting?
Yeah, but just if I may just comment
Yeah.
on that particular point first, is 'cause one of the things I found that really surprised me, but was very interesting, was that even scientists very often don't know the kind of backstories for all of these things. But I mean, if you, I have a son who's a doctor, and he knows everything you need to know in order to practice medicine, and he's a surgeon. Very, very, very good at it. But I just sort of said to him once, why is it called Parkinson's disease? And he had no idea. He knows everything you need to know about Parkinson's disease as something that you treat, but he doesn't know who Parkinson was. And I found
Mhm.
that with lots and lots of scientists that you ask them just the basics, the basic history of their own fields, and they know all of the technicality of everything, but they don't actually always know the human side of things, the human story and how it developed. So I was gratified to discover that a lot of scientists actually found the book quite useful for themselves. I mean, a physicist isn't going to learn anything about physics from my book, but he will learn a lot more about what kind of a person, Albert Einstein was, or how Albert
Mhm.
Einstein got to become Albert Einstein, or, Isaac Newton, people like that. And that which brings me to the specific question you just asked. And I think that probably the person that I most admired and found most amazing in the whole book was Isaac Newton, because he was, on the one hand, he was unquestionably one of the most brilliant people who ever lived. I mean, probably in the top half dozen people who ever walked the earth. Um, just could think of things that nobody had ever thought of and probably wasn't ever going to think of, and just conceive of how the universe was put together in quite an amazing way. But at the same time, and kind of delightfully, he was also often sort of an idiot. I mean, he did a lot of dumb things. He one of the just basically one of the basic things he did was he once stared at the sun for as long as he could just to see what would happen. And of course, we've all known since we were 5 years old, you don't do that. You don't stare at the sun because it will make you go blind. And he didn't go blind, but he actually really, really hurt himself. I mean,
Mhm.
he strained his vision considerably and had to spend a couple of days in a darkened room in order to recover from the experience. But he did a lot of kind of dumb things in an experimental sense, experimenting on himself, in effect. But at the same time, he had this brain that could think things through way, way beyond most of the rest of us, or all of the rest of us. So I like that kind of juxtaposition of genius and idiocy in the same person.
And I mean, I feel like that's pretty true and universal, right? Of like, there's so many people who are maybe geniuses in one area or one field, and then you put them in a different context and they are just helpless and maybe not as bright. It doesn't seem like genius is always evenly distributed across all aspects of life.
And you put your finger right on it. And the one thing, and I think there's a great deal of comfort in that too. The idea
Mm,
that everybody is human and every human is fallible. And no matter how good you are at something or how smart you are at something, there's going to be other things that you can't do half as well as even I can. I mean, there'll just be certain things that you do brilliantly and certain things that you are incapable of doing. Um, and that, there's plenty of examples of people who super smart people who've done kind of idiotic things that have ended up ruining their careers or messing up their lives.
mhm.
So yeah, it's entirely possible to be very, very brilliant and very foolish at the same time.
Reading the new book or the updated book, I should say, there are, like I said, so many different scientists and figures in it who you write about. Obviously, a lot of the very well-known ones, Isaac Newton, Albert Einstein, those kinds of legendary names. But there's also many, many more names that readers may not be familiar with already or may not have heard of. Is there anyone who you feel like is kind of an unsung hero of scientific discovery that deserves more credit, that you shine a little bit more light on in the book, that should be kind of considered up with those other famous names?
Yeah, yeah. There's quite a few, as you say. The one that always leaps to mind for me is a guy named Henry Cavendish, who is an Englishman. His two of his grandparents were dukes, so he came from a
Mm,
very privileged background. And he was notable for two things: for being very brilliant, but also for being in pathologically shy. He could not bear to have people talk to him. He would actually sometimes flee a room if people addressed him. He was just painfully shy. But he was also, because he was so solitary, he did an awful lot of really important scientific work. This is in the 18th century. And one of the things he did was, from his home in London, he he figured out how much the Earth weighs. It was a very complicated experiment that involved some spheres hanging on string or
mm.
thread, um, and he had to work out how much they deflected. I mean, I don't know the technicalities of how this all worked, but he had to. It was very specific and precise, and he had to actually retreat quite a distance so that he didn't influence the way the spheres moved. I mean, he had to measure these things extremely precisely. But the upshot was that in the 18th century, he worked out how much the Earth weighs by doing this experiment in his home in Clapham in London, which is just kind of extraordinary. Because, I mean, if you think of it, if it was up to you or me, how would you figure out how much the Earth weighs? How you wouldn't even begin to know where to start. And here he was doing it with very basic things way before the invention of computers and all kinds of modern implements long time ago. He also did a lot of other very basic fundamental work in chemistry and physics. I didn't tell anybody. He would do these experiments and come up with incredible solutions, excuse me, and then write everything down in his notebooks, but not tell anybody. So it was very often, when people later discovered these things, it was only realized that he had found out, 50, 60, 80 years before them, but had never bothered to tell anybody about it.
So, I guess, listener, if you're working on any kind of scientific equations that you think could be really impressive, make sure you share those with people so you get credit. Don't let them be discovered
was
until after you're gone.
Yeah, I mean, it's extraordinary. He didn't care about getting credit. He was all for him. It appears that all was mattered was just satisfying his own curiosity. He would
Mm.
want to know why, what made water, for instance, what you had to do in order to create water, what was the chemical composition of it, and once he found these things out, he was completely satisfied to just keep it to himself and not go out and tell the world. Oh.
In touching upon, something that you said about like, how be just trying to get into the mindset of, I'm going to go outside and without access to any kind of computers or digital technology or what have you, I'm going to independently figure out how heavy the entire planet is. Um, it does kind of there is so much of that in the book, of course, of kind of the capability and genius and creativity of human beings. In a way, it reminds us that we were able to achieve so much before computers, and without computers and without smartphones and without the internet and things like that. It's really kind of inspiring, and also sort of, for me, reminds me that all of this stuff is helpful in many ways, but it's also creature comforts, and the majority of human achievement and accomplishment has been done without this stuff.
Mhm. The other thing that's very interesting, I mean, you're absolutely right when you say that. The other thing that I hadn't thought about before I started working on the book, but really was driven home to me, was that, I mean, we all tend to think of scientific advances as being, these great eureka moments when,
Mm,
like an Einstein or a Newton, or they have these fantastic ideas. And of course, those eureka moments are immensely important to science and to human knowledge. But the other part that is at least as important is just is just, hundreds of thousands of anonymous scientists working on very specific problems and just adding some little tiny, grain of extra knowledge to the great pile of what is known. It's not just about fantastic breakthroughs, but it's this kind of very gradual accumulation of knowledge by people adding just little bits to the great pile of what is known. And that was something that I hadn't thought about before I did the book. But one of the things I realized in talking to scientists is that, hardly anybody gets to be at Einstein or do anything that's that important, or even just important enough to win a Nobel Prize or something. I mean, those breakthroughs are very rare. But there are zillions of very, very brainy scientists who make small discoveries and add to knowledge, and all of that put together is really the sum of what humans know, and that is, as you suggest, very, very impressive. What we as a species have achieved is, in terms of knowledge and achievement, is really quite extraordinary. We haven't been around all that long, I mean, civilization does not go back all that far, really, when you think of the kind of great spans of time that have taken the Earth to, to become habitable, and how long the universe has been around. We're just a tiny last few seconds of the clock of time.
Yeah, that is something that is also driven through in the book of just how big, how small really we are, and how big not only the universe is, but also time itself, and how long ago things have existed, and everything. You do a really great job of communicating all of that with analogies or metaphors or things like that kind of really help visualize these things in ways, or help you understand them. To your point about realizing the kind of gradual progress of scientific knowledge and the evolution of that, I feel like that was something I was learning from the book as well. Of that, like, it occurred to me for the first time that the periodic table of elements was something that had to be designed by a person, because if when I think about the periodic table, I'm like, well, it makes so much sense because it's look how well arranged, and there's this logic to it, and it works on, there's this cluster, these columns mean this, and these rows mean this, and there's this really amazing uncanny symmetry to it. But that was not a foregone conclusion. It's not like God came down and gave Moses the periodic table, like tablets or something like that. Someone had to realize this and put it out and lay it out together in that kind of way.
Yeah, of course, and yeah, and thank goodness, thank goodness that happened. I tell you, the person that, in many ways, I was most fond of all the people I interviewed, was a very nice guy named Len Ellis at the Natural History Museum in London. And Len Ellis is retired now, but he was their moss man. He was the world expert on mosses. And the thing is that he took me into his little sanctum at the Natural History Museum, and he was quite excited to show me all his mosses. He's got thousands, thousands and thousands. And the thing about mosses is that when you collect them, they dry, and they look like nothing. They just look like a little sprig of kind of brown materials, the sort of thing that you, I don't know, find in the cuffs of your pants or something if you've been out in the garden all day. And but what if you moisten them, they spring back to life. And he would say, so, oh, this one, look at this one. This one's from Sumatra, and he would moisten it and show me how green it was. And then he'd say, oh, and here's another one that I found in Japan on a trip to Japan, and he knew every single moss, and every single moss was incredibly important to him. And the thing is, as a outsider looking at these, every single moss looked like every other moss. They didn't look, any of them didn't look different at all. And I just sat there sort of staggered that he could tell the difference, but also that he could get excited about it. That this to him, this was the most exciting thing in existence, was finding mosses and working out the differences between them. And I just thought, it just occurred to me this, how great it is that the world has people like that in it, because we need people like that. We need people who are prepared to devote their lives to mosses, and other people who are prepared to devote their lives to jellyfish and lichen and everything. And that is exactly what science does for us. But as I say, it's mostly people doing little tiny things that add to this great sum of human knowledge.
And not just that, but it's also sort of they're pursuing these really niche passions that they just inherently care about or are really curious, or just something clicks in their brain where it's probably the moss scientist probably didn't get into moss because there was a lot of commercial opportunity there, or a lot of financial reward, right? They just, it's something inherent to them that they're like, this makes sense to me and I need to pursue it.
Yeah, yeah, yeah. And very often it's because they realize that they could have kind of have this field to themselves,
Mm,
and they could do, work on projects to their heart's content. And as I say, because I just think it's fantastic that we live in a world like that, where there are people all over, scientists all over the world, doing all of these very specific, arcane things that would bore most of the rest of us out of our minds. I mean, I could not spend my life doing mosses or lichens or other things, but thank goodness there are people who aren't like that, who will do that, and I think that's fantastic. And they are really the heart of the book, or the heart of
mhm.
scientific development. The Einsteins and Newtons and people like that are the great rarities.
Is there one, something that I enjoyed reading the book was that, you talk about a lot of the evolution of science, and that evolution is not, like we've been saying, it's not something that you jump to immediately the most developed or fleshed out version of a theory or a natural law or things like that. There's a lot of kind of missteps or zigzags along the way. Can you give an example of a time that the scientific community was completely, in hindsight, off base with something, but they really accepted this to be a true thing?
Well, one of them, I suppose, was that until an astronomer named Edwin Hubble came along in the 1920s and 30s. Before that, it was thought that the universe consisted of just one galaxy.
Mm,
That there was just the one galaxy, and he worked out that actually there's not one galaxy. There's an unknowable number of galaxies. There may be effectively an infinite number of galaxies in the universe. And the idea or another one that leaps to mind is, and this, even when I was in high school a long time ago, but when I was in high school, they didn't understand plate tectonics. We didn't know how continents moved around, and they didn't even realize that continents moved around. And I'm sure, like almost everybody who's ever looked at a globe as a kid, you can see how South America and Africa look like if you two
yeah.
puzzle pieces and fit together very neatly. And nobody used that to think, oh yeah, those two were probably attached at one point. It was we were quite spectacularly ignorant, or very slow to catch on to these things. And it really wasn't until the late 1960s that things like that began to be understood, that how the earth is made up of all these plates that move around and cause earthquakes and cause mountain chains to be built, and well, everything, all the dynamics of the earth, and may even contribute very significantly to our existence. But it may be that it's one theory is that without tectonics, life on Earth probably would never have might never have got going at all, or might have just
Mhm.
been a cellular forever, and there wouldn't have been any us or anything complex at all.
Thinking about that more, something I did want to kind of explore a little bit was, you talk about how Earth is uh, a cosmic anomaly. I don't think that is going to surprise anyone listening. I think that's pretty, we know that we're on a very unique and special planet. But what specifically is it? What are some of the factors that go into Earth that make it really the right environment for life to flourish, for life to exist? Like, what are, because you do such a good job in the book of explaining all of these things, which once again are not necessarily, they were never destined to happen. Some of these things exists on a like super thin razor's edge style coincidence that this is happening. Would you be able to take us through some of those?
Well, yeah, I mean, it's when you think about it in every possible way, we shouldn't be here now because I mean, the odds are completely stacked against us.
Right.
So
Hmm.
for you and me to be here right now, um, both as individuals and as species, is so completely unlikely. I mean, if you just think about it as individuals, obviously, you could only be here if your parents had mated and their parents before them, and all the way back, grandparents and great great grandparents and all of that. But when you think about it, that goes back all the way to the dawn of life on Earth. That
Hmm.
since life was created on Earth, the chain of pairings that necessary to end up with you now, there's not been a single failure in 3.5 billion years. There wasn't a single one of your relevant ancestors on your mother's side or your father's side that failed to produce an heir that would eventually lead to you. That's quite extraordinary. 3.5 billion years of genetic success behind
Hmm.
every one of us. Um, so as an individual, just the idea that we get to exist is, we are so lucky to get to have the privilege of having life. But then there's also the whole question of humanity. I mean, life on Earth itself is quite extraordinary that it happened. As far as anybody knows, it only happened once. So, there was one kind of magic moment, a moment of creation, and that all life that of all types that exists on Earth now all descends from that same one magical moment of creation. But in order for it eventually to end up with Homo sapiens, with human beings, modern humans, we had to have just one stroke of good luck after another because, I mean, as you well know, when the dinosaurs ruled the earth, mammals were just tiny little creatures that hid underground, and it required the dinosaurs to get wiped out to make a planet that was attractive and accommodating to mammals. And mammals could then grow up and fill all the niches that dinosaurs had occupied. But we've had that kind of thing, that kind of good fortune happen again and again and again throughout the long history of planet Earth. There have been loads of extinction events and lots of things have gone wrong. And the whole chain of coincidences necessary to get from being a single cell organism to being a modern human. It's just been one lucky break after another. So both personally and as a kind of as a species, as a family of beings, we have been so lucky that it's almost unbelievable that we're here today.
And taking it even further in terms of the origins of life, but you go even further back in the book and point out that um we are all atoms and we all exist on an atomic level, and the history and origins of the atoms that are in us is even somewhat more spectacular in my mind, of the connections that the journeys that the atoms that make us up or comprise us, what those journeys that those atoms have been on, and they are now currently in us on making a pit stop onto wherever they're going next.
Yeah, yeah. I mean, I think it's just the most wonderful thought is that we are mostly made up of atoms that were created in distant stars and distant galaxies, and were just kind of blown out into space, and they all went drifting through space, and eventually some of them ended up on this little planet in the middle of nowhere, and somehow, through the great miracle that is life, they came together to make each one of us. I mean, you have trillions and trillions of atoms. I think the number is 32 trillion, somebody estimated that or that's your little package. That's what makes you you. And all of these atoms come together to make they do everything necessary to make you you. And you don't have to think about it. You don't have to you don't have to think, oh, I must remember to digest my food after the next meal, or I
Mm.
must I must remember to make more red blood cells because I need lots and lots of new ones every day. All these things happen automatically. All of these little atoms form molecules which control and look after you, and we just take that for granted. But when you stop and think about it, I mean, it's amazing that you have that kind of cooperation because nobody's instructing them. I mean, it's not like a control center is somewhere in your body that's telling all of the cells in your body what to do and how to get together and how to organize themselves and cooperate. It just happens, and to me that is well, that's the miracle of life. But that really is genuinely a miracle.
And if you don't feel just a sense of kind of like gratitude or appreciation just thinking about that, um, I think you can also, even though it takes a little bit of work to get there mentally, something else that I found a lot of gratitude in and really makes you kind of appreciate the moment and our lives and doesn't really makes you forget about a lot of kind of maybe petty stuff or whatever's irking us on any given day or any given moment. Going back to what you're saying about the odds of any of us existing or existing on this planet being so slim and just requiring so much luck. You do a good job in the book of writing about a lot of extinction events, not only ones that have happened, but things that could theoretically happen, which I don't think a lot of people are aware of. Like, I think a lot of people would be aware that an asteroid hitting the planet would probably be very bad, but you do a really great job of illustrating exactly why that would be bad and how exactly that would go down, both for the people um, at the kind of crash site of the asteroid, but then everyone else, uh, even in the hemisphere of the asteroid crash site. Would you be able to talk a little bit maybe about the asteroid or something else that I thought was kind of another fascinating but also terrifying concept was the super volcano that you write about being under Yellowstone National Park, which we all like Old Faithful, right? And the geysers are like, oh, that's fun, but good Lord, Yellowstone National Park is terrifying when you really find out what's going on beneath it.
Well, and I'm sure you remember from reading in the papers, there was a very good example of Yellowstone a year or so ago in the summer. Was it just last summer or the year before? But there was a sudden eruption.
Mhm.
And geysers just erupt sometimes. And this one was right beside a boardwalk where people were walking. And it was a kind of just such a stroke of luck that it wasn't exactly under the boardwalk and blew the whole thing up. But the whole thing, I mean, just suddenly from out of nowhere, totally unexpected, just burst forth, and a new geyser just shot 100 feet or more into the air, and all these rocks and super heated water and all kinds of stuff just came raining down, and miraculously nobody was injured. A lot of people got covered in gunk, but nobody was injured. But I mean, yeah, it's Yellowstone and a few other places on Earth are really really quite underneath there. It has been in the past and is certainly capable again of being what's called a supervolcano, which is just would be a massive eruption which would throw out ash and that would cover most of the United States and a good deal of Canada and Mexico. And it would really, really, if that happened again now, it hasn't happened for hundreds of thousands of years, I believe. If that happened again now, it would push us to the very brink of our ability to cope. And what we're increasingly finding is that Earth is I mean, Earth is a dangerous place. It can do a lot of things. It can have big volcanic events. It can have big giant earthquakes. It can get hit by asteroids and comets that passing through space, and these have cataclysmic events. Often they don't often always lead to extinctions, but what they can do is reduce populations to practically nothing. I mean,
Mm.
if a big asteroid hit Earth now, humans as a species might survive, but it's entirely possible that some billions of us would die in the process, and what would be left would be just a sort of remnant population of humans and other animals, and they would, have to claw their way back, and it would probably take many, many generations to get back to a kind of civilized comforts that we enjoy now. So we're very, very vulnerable in principle, but luckily these things, they don't happen. They don't happen very often. They can happen, which is this, which is a scary thought. There could be a super volcano could erupt tomorrow, or an asteroid could slam into Earth next year. All kinds of things could happen, but as our own history shows, they don't happen very often. But there's still plenty of things out there that can cause a lot of havoc.
And I guess for me, when I think about those things, because they are, for some people, they might find those as reasons to be anxious or reasons to be depressed, but I find like those things almost have the reverse effect on me, where it's almost like those senses, like it's impossible to even like it just overwhelms any of those feelings that I could have of like an asteroid coming, like, and there's nothing that we can do to control it or prevent it. And you write about in the book, like, there are scientists who study asteroids and things like that, and they're like, oh yeah, it turns out this really big asteroid was actually like kind of near Earth, and we just found out about it while it was passing. So we really would not have a lot of advance notice, and we also would not probably be able to do anything about it. I don't think we're
Yeah,
going to
yeah.
be sending astronauts up like in the movie where they go put the bomb in the asteroid, but um, I find it kind of comforting in a weird sense. And I was kind of wondering, like, as someone who hasn't been engaging with all this stuff, not only now but also 20 years ago, you're writing about everything. Like, what kind of sense of meaning do you get from that? Like, how does that affect you on a spiritual level, like in terms of faith? Does that intersect with science at all for you?
Well, I'm happy. I'll happily answer that. But just what you were just talking about kind of reminded me of something. I talked to the Britain's astronomer royal, really, really smart and very, very nice man named Martin Rees, when I was doing the new edition 2.0. And we touched on this about, I asked him if he was worried about asteroid strikes and things like that. And he said to me, he's in his 80s, he's kind of seen everything. And he said, no, he said, it's just a waste of time to worry about those things. He said, if anything really bad is going to happen, we'll almost certainly do it ourselves. We'll have a nuclear war, or we'll make the planet in some way. We'll just mess it up with global warming or something. He said, humans are perfectly capable of being self-destructive. You don't need to look to outer space for explanation for the dangers that we faced, which I thought was an interesting point. Now, in terms of spiritualness, I'm not a spiritual person, and the book doesn't really touch on that. But having said that, and I talked to a lot of scientists about this, there isn't anything in in conventional scientific belief that is incompatible with being religious, because I can say, the Earth began, life, I'm sorry, the universe began with a Big Bang that created everything that's in it. But then, if you are a spiritual person, if you're a religious person, you can say, well, what caused the Big Bang? And and no scientist can answer that question. No scientist can say what was before the Big Bang, what would actually precipitate the Big Bang. And when it comes to that, a God is some sort of providence is as good an explanation as any. So there's plenty of room for conventional science and profound religion to coexist very comfortably. And you don't need, I don't want to get into controversial area here, but you don't need, to have a literal interpretation of the Bible and believe that exactly everything that's described in the Bible, like the earth happened in 7 days, they were created in 7 days, or all of that, in order to believe in God and have religious belief, but also to be, kind of faithful to the fundamentals of modern science. They can work together very, very comfortably. And I know a lot of scientists who are, they're very religious, and a lot of scientists who aren't.
Mm.
And there's plenty of room for both sides there.
So kind of thinking about um, not necessarily endings in terms of asteroids hitting the Earth or things like that, but I am kind of curious to hear about where you feel like you are as a writer, because I know that back in 2020, you had said that you were retiring or that you had retired from writing books. Um, I'm, of course, talking to you right now after 2020, where you have a new-ish book coming out. What is the state of Bill Bryson's career right now as we're in late 2025?
You know, you're absolutely right. I decided that I was going to retire in 2020. I made that decision in like 2019.
Hmm.
I tried to be semi-retired for a while, and that just doesn't work. You're either retired or you're not. And so, and then, out of the blue in 2020 came COVID, and we all retired.
We
I
all
mean,
were kind of retired, yeah.
and it made it really easy for me to essentially be retired. And I loved it. I mean, I really enjoyed all kinds of aspects of not having to write books and work anymore. But writing is hard work. I mean,
Mm.
it was it wasn't something I had a compulsion to do. I've enjoyed it. I had a marvelous career, wonderful life, and it's brought me all kinds of adventures and things. But I also just like to. I've got a big family, a lot of grandchildren and stuff, and I wanted to just have enjoy life and travel with my wife and do the things you do when you're retired. I, and as we were saying earlier, eventually I came to a point after I'd been retired for, I guess, about 4 years, 3.5, 4 years. I did think, actually, I have to suspend my retirement to bring this book up to date, because I thought when I was doing this, I thought this is kind of in my mind, my last hurrah. This is my last project. But the one thing, if the one piece of unfinished business I have professionally was bringing in short history nearly everything up to date. And of course,
Mm.
it's just come out this week, and in physical form, which means that it's already becoming out of date again. I mean that's the thing about books, is that once they're printed, they start to get there will be new developments, new discoveries, things will come along, and certainly in 20 years from now, when I'm long gone, there will be need for somebody else to update it, or probably replace it with something else altogether. But this was my effort to just try and give it a little more life, because I the book's been very, very good to me. I've really, really enjoyed it, but I do think that it's had a good life, and I didn't want it to sort of die from neglect. I wanted to try and rejuvenate it.
Give it one last push into the future while you still have the opportunity
Yeah,
to
and I
give it
think
that
I mean
push.
I think that even if there are amazing discoveries in the coming years, which there will be, I think it certainly should have at least another good 10 or 12 years of people are pretty forgiving. If somebody discovers the source of dark matter tomorrow, they'll realize that my book was written before that was discovered. So I think it won't be overwhelmed by discoveries for at least a decade or a decade and a half. But gradually, of course, it will. I mean, there'll be all kinds of new discoveries and new developments and new thinking, new theories. That's the way the world works.
Is that something that you've given any thought to about, like, would you ever pass the baton or torch to someone who's going to take over updating the book when you're no longer around or no longer able to do that? Is that something that you would actually consider doing?
It's not something I've ever thought about, but I'd be very happy to think that that might happen. You
Hmm.
know, it would. I would have no objection to that happening. I mean, in fact, I'd be thrilled if some eager person 20 years from now or whatever, um, came along and brought it up to date again. Because I mean, the thing to remember is an awful lot of the book is history, and so
Mhm.
quite a few chapters in the book that didn't need a huge amount of change. It's just certain fields that changed a lot, physics being one of them. And the whole anything that involves genetics and the study of DNA and things like that, that has changed a lot, and that will continue to change a lot. I mean, there's no question that people will start to be able to do all kinds of things with manipulating human cells and dealing with diseases and which will be wonderful. But
Mhm.
so somebody at some point in the future, if the book is going to continue to have any value, somebody will have to go in there and bring it up to date again.
So it sounds like you might be going back into are you going back into retirement, or do you have anything else in the works? Or are you noodling anything at the moment that you think you might tackle next?
No, at the moment, I'm really intending to be retired. I,
Hmm.
I did enjoy it very, very much. I mean, I did enjoy not having. It's always, it's weird because I enjoyed my career a lot too. I had a fantastic professional life, and it's obviously very rewarding. But as you get older, I think you just get less ambitious, and you just want to relax, and you become way more conscious of that life is a finite thing, and maybe to be a little bit selfish about what the time that remains to you. And what I really want to do is spend time with my kids and my grandchildren as much as I possibly can, and also to do things like travel with my wife. I spent years and years traveling alone because I'd be on magazine assignments or doing research for books, and
Hmm.
my poor dear wife, stayed behind and raised the kids, or looked, she ran the house while I was away out having this great life. And so what I've been trying to do ever since our kids have grown up is take her off to some of these marvelous places that I've been able to go to and show her. We're going to New Zealand and Australia in a couple of months, and I'll be taking her to some places that I've been to and she hasn't seen. So I'm very excited to be doing that.
That sounds awesome. That's wonderful. I think you definitely deserve to have a fun, real retirement this time, hopefully. Granted, all of us will not be, retired alongside you like we were during 2020 with the pandemic, but definitely very, very well deserved. You've been very generous with your time today, and I'm feeling very lucky and privileged that I got to speak with you before you perhaps go off onto more of a real retirement. Before I let you go, I was curious to hear, now that you are on the precipice of retirement and you're thinking about your career and you're thinking about your life, you talk about in the book how some scientists have tried to figure out a theory for everything, or a theory of everything, a unifying theory of the universe. In your mind, thinking about your life and your career, like, what is Bill Bryson's theory of everything? Like, advice or the lesson that you've learned, or just anything.
I think we've come pretty close to touching on it explicitly in this conversation. And thank you, by the way. I've really enjoyed it. This is the kind of thing I do miss when I'm retired. Is that having that sort of the stimulation of conversations with interesting people. But the thing I think is really the fundamental thing that I knew already. We all know already, but really that I came away with from the book is life is amazing. Our existence is wonderful. And there really shouldn't go a day in your life that you don't stop and think, I'm so lucky to be here. Because as I say in the book, your existence is bounded by two very long infinities when, there was a massive amount of time when you didn't exist at all, and you were born, and you get to a few tens of years to get to enjoy this marvelous thing called life. And then you die, and all your atoms, separate and go off and become other things, which is kind of wonderful in a way that they will all go off and become something else. They'll be useful in some other ways. Every bit of you that makes you up now will just kind of dissolve away and become part of some new systems elsewhere. But there will be no more you. And so when there is, in that pretty brief span, when we get to be alive and exist, I think that's the most amazing thing. Which to me, that's the main point of the book, is that existence is pretty miraculous and really should be appreciated.
I can't think of a better note to end this episode on. So, Bill, thank you so much. It's been a pleasure getting to chat with you today. Listener, the book, again, is A Short History of Nearly Everything 2.0. It's available now at your local Barnes & Noble store and online at bn.com. If you're looking to brush up on some science that you may have forgotten over the years, or you want to expand your mind, learn something new about this truly incredible existence that we find ourselves in, I highly recommend it if you've enjoyed our conversation here today. Bill, thanks again so much. I hope you have a wonderful retirement.
Thank you very much, Chris. It's been a real pleasure. Thank you.
Thank you for listening. Poured Over is a Barnes & Noble production. To help other readers find us, please rate and review the show wherever you listen to podcasts.